Good afternoon, my YouTube viewers. Crystal here. I'm here this afternoon because I wanted to make another video for you. I've been working on this all day long. I had originally been working on Facebook Profit, but I just could not get Facebook Profit to work the way that I wanted to do it. So I decided to work on the bagging, and I got bagging up and running, a much better accuracy than Facebook Profit. So I think it's better to use bagging than it is to use Facebook Profit in this particular competition question. This is a competition question from Analytics Bit Higher, and it was a competition question from about 2018. And whenever I updated, used some more better techniques, I was able to improve my score. I was able to get like a 94.6% accuracy on the validation set, and whenever I put it on the solution checker, I had an 8.9 RMSE, which is very good considering that the best RMSE was 6. So my RMSE was less than 3 points lower than the best score. So that's good that my RMSE was so good. And as a result of that, because I got such a high RMSE and I did so well, I thought that it would be a very good idea if I went ahead and made a video on this and did a code review. So that's exactly what I'm going to do. I'm going to do a code review, and whenever I do my blog post, then I will leave a link to the my GitHub account on my blog post. So if you want to get the code, then you'll have to read my blog post with Medium Publications. So what we did was we actually made this IPYN program on Google Colab, and the reason why I used Google Colab is because it's online, it's free, it's got the libraries already installed, and all you have to do is import them. So you don't have to worry about importing libraries on your computer. You don't have to worry about installing the most current version of Python. That's done for you already. And then so all you have to do is just get to the business of coding, which is what I want to do, is code and solve problems. So the first thing we'll do is we'll go over the problem statement. And the problem statement is, you are working with the government to transform your city into a smart city. The vision is to convert it into a digital and intelligent city to improve the efficiency of services for the citizens. One of the problems faced by the government is traffic. You are a data scientist working to manage the traffic of the city better and to provide input on the infrastructure planning for the future. The government wants to implement a robust traffic system for the city by being prepared for traffic peaks. They want to understand the traffic patterns and the 4 junctions of the city. Traffic patterns on holidays as well as on various other occasions during the year differ from normal working days. This is important to take into account for your forecasting. To predict traffic patterns in each of these 4 junctions for the next 4 months. The sensors on each of these junctions were collecting data at different times, hence you will see traffic data from different time periods. To add to the complexity, some of the junctions have provided limited or sparse data requiring thoughtfulness when creating future projections. Depending upon the historical data of 20 months, the government is looking to you to deliver accurate traffic projections for the coming 4 months. Your algorithm will become the foundation of a larger transformation to make your city smart and intelligent. Well, the thing that I have to say about that is they don't tell you what country this city is in. Analytics Vidhaya is, I believe, an Indian company, but they don't tell you what country the city is in, so you don't know about the holidays. They say that they want you to take holidays into consideration, but it's going to be very difficult to take holidays into consideration if you don't know what country it is, because every country has different holidays. I will say Christmas. You know, Christmas is going to be the 4th week of December. New Year's is going to be the 1st week of January. So those are 2 holidays that you can calculate into your projections. But one thing that I did do was, one of the things was I used these date time functions, and I calculated the week of the year. So I calculated the hour of the day of the week of the year, the month of the year, and the actual year itself. So you can get the holidays from the week of the year if they're standardized holidays, such as Christmas or New Year's. But if it's something like Easter that is dependent upon the moon cycle, it's going to be very difficult to find out when the holidays are if you don't know what country it is. And even Christmas, it's going to be difficult to find out when Christmas is, because different countries have different dates for Christmas and different countries have different dates for Easter's. So they didn't give that information, and because they didn't give that information, it was difficult for me to calculate holidays, but I did calculate the weeks of the year and the days of the week. So that's one thing that can be taken into consideration. So what we did was we imported the libraries. So we imported pandas, NumPy, Matplotlib, and Cbarn. And those are some common libraries that you're going to use in many Python programs. And then what we did was we imported our CSV files that we downloaded from the Analytics VidHaya website. And when we downloaded this from the Analytics VidHaya website, I saved it to my personal GitHub account. So now I can access those files whenever I want to. So you've got a picture of the train file. It's got date, time, junction, vehicles, and ID. The test has date, time, junction, and ID. It doesn't have the vehicles. We have to put the vehicles in. And then so this is just some information about the type of file it is. And then so what we have here is we're checking for any null values. And in this instance, we don't have any null values that we have to separate. Now what I did was we don't have any null values that we have to impute. But now what I did was I had to separate all of this information from the date time before I could use it. And so we used the Python datetime library to do that. So I think that this library is already in Python because, well, no, it's in pandas. But so the first thing I had to do was I had to convert the date time actually to date time, which is in the pandas library. And then so we had to make errors equals coerce. So that's what we did. We had to actually convert the date time to a date time using pandas. And then what we did was we created a column and we called it hours of the day, and we used date time hour function to do that. We created a column called days of the week, and we used a date time function to do that. We created a column called weeks of the year. We used a date time function to do that. We created a column called months of the year. We used a date time function to do that. And then we created a column called year, and we used the date time function to do that. So we used all these date time functions, and I believe it was actually the date time function that improved my score. So now what we have to do is we have to prepare the data. So what we're going to do is we were going to create a variable called ID train and ID test and put that information from train ID and train test ID in it, because we're going to be dropping the ID column from train and test because it's not necessary, but we do need to go keep that information to hand in case we need it somewhere else, which we will need it. The test ID we will need somewhere else. And so now what we've done is we've plotted a graph of the data. So you can see here where we plotted this graph of the data. And you can see it's not linear. We'll just put it that way. It isn't linear. The next thing we do is what we want to do is we want to define our X and our Y variables. And so X is train vehicles values. That's Y is train vehicle values. X is train drop vehicles date time. X test is test drop date time. So that we've got our X, Y, and our X test variables. The next thing we want to do is we want to split our X data set up for training and validation. So X train, X val, Y train, Y val equals train test split. X, Y test size equals 1. Random state, no, test size equals 0.1. Random state equals 1. And now what we're going to do is we're going to use pipeline. So model equals make pipeline, standard scaler, bagging regressor, base estimator is gradient boosting regressor, max depth 5, min samples split equals 2, loss equals LS, estimators equals 400, learning rate equals 0.1, random state equals 1, fit X train, Y train, and print. We've got our model score that we can print is, and we got a 95%. And I think that if I increase the max depth, and if I increase the max depth, I think I can get the accuracy higher. I do believe I can. So now what we're going to do is we're going to predict on the validation set. And we predicted on the validation set we had a 94.76%. And then so we create a data frame so you can compare the actual values against the predicted values, and you can see that they're very close. And so what I might do later is I might actually go back and increase my max depth to 10 to see if I can improve my accuracy even more on this problem. What we did was we plotted a graph of the predicted values against the actual values. And then what we did was we predicted on our test set, and we created a data frame to put the ID number and the predictions in the data frame. We converted that data frame to a CSV file, and we saved the CSV file, and we submitted it to Analytics VidHaya. And when we submitted this CSV file to Analytics VidHaya, I got an 8. It was close to 8.9, which was like less than 3 points less than the best score. Less than the best score. So, I think I did a pretty good job, which is why I wanted to make a video on this. But I'm going to do some more work on this. I'm going to increase my max depth and see that if I increase my max depth, can I increase my accuracy even more? Because that's the name of the game, increasing your accuracy, getting your accuracy as high as you can possibly get it. So that concludes this video. If you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I have my email address to my PayPal account in the description box down below. And thank you so much for watching this video, and I look forward to making more videos for you in the future.